Hi there, guys. This is Víctor. Super happy to be here speaking today about the cybersecurity status of PX4. So hopefully you'll get to enjoy it. Let's dive into it. Right. So before diving directly into security, I wanted to share a few words about some past contributions myself and my team did. So we actually started back in 2013 with this Beagle pilot project, which was actually pretty early phase, just about a month before PixHawk was actually released. And the goal of this Beagle pilot project was essentially to port Autopilot to Linux. I did this together with other students and mentored by Andrew Trittel. And it took us about a year to get essentially the first flight. You can see over there a video that shows my real bad piloting skills, which haven't improved, frankly. But still, the first Autopilot copter flight, which essentially got us very excited, especially because about a month after that, a Drone Code Foundation was first announced and created, which essentially got, I guess, all of us into this community to start contributing together and pushing towards the same direction. We certainly did so, and by the end of 2016, we released this second video, which shows the launch of a version of PX4 that has been customized to replace the communication middleware, MicroOrb, for a fully fledged DDS implementation. Essentially, we had a PX4 version that directly used ROS2 for communication across the flight stack submodules, across different essentially elements within the Autopilot. This allowed us to replace bridges that you might be using, such as MapROS, and directly interoperate with ROS2 natively. It also allowed us to further optimize latencies and essentially get an overall better performing soft real-time Autopilot, which essentially we were aiming for, and which led us also to essentially achieve some hard real-time capabilities, which we did by synthesizing some of the Autopilot aspects on hardware directly. Really exciting stuff, which unfortunately got interrupted, not for bad reasons, but for even better reasons. We got acquired. That was real good, real fun. Unfortunately, we had to pivot due to essentially our owners at the time. After a few months, they decided to move towards modularity for industrial robots. We essentially started building safety certified components for industrial robots, which was also real interesting and got us to learn lots of things. But after a few years, essentially Alias Robotics was created by some of the original founders of Alias Robotics. And ever since 2018, it's been essentially helping companies and manufacturers and end users to secure their robots and robot components. So security, let's dive into it by starting actually to review slightly this concept of DevSevOps, which is a centric concept that I wanted to share at least, and which should somehow drive all of our minds towards getting a more secure landscape in PX4. DevSevOps is a series of practices that aim to implant security at every single phase of the essentially flow across development through deployment, production, and post-production. You can see here some of the tasks within those phases. Every single one should consider security. How? You've got a publication over there we released, by the way, in case you wish to further dive into this. But answering the how question, I got this diagram here, which hopefully clarifies many of the essentially items that should be executed within these phases and tasks. So for example, in development, we have the plan task, and within the plan task, there are a number of items we should take into account if we want to have a more secure approach. So in this case, perform threat modeling. Once we dive into the coding, essentially task, we have also some attributes to consider, the same for build and so on and so forth. In this presentation, I'll be touching into a few, mainly threat modeling, also a bit of static analysis, SAST, and a bit of flow management. And of course, I'd love to touch into all of them. Very happy to do so offline. So if anyone has interest and has resources actually to contribute to this, please reach out and I'll be more than happy to continue the discussion offline. Touching into these few bits, again, due to time matters, and diving directly into threat modeling. But before that, just left here a couple of slides to clarify definitions, how we do define security flaws. And this is important because according to our research so far, different organizations have different interpretations. So this is ours. The main difference is that for us to accept a vulnerability, there needs to be evidence. It needs to be exploitable. Many other organizations accept the so-called theoretical vulnerabilities. We typically aim to provide evidence or at least have clear research on them. And when possible, provide an exploit. Though again, this requires resources for accelerated mitigation. I've also cooked in here a few of the resources I've used to put together this presentation. So if you're really interested in security and security for PX4, go ahead and check this out. Very, very interesting. And thanks to all of these authors who definitely have contributed a lot these last few years. Now, diving into the few bits that I'll touch in this short presentation. First one, threat modeling. It's critical to understand what's your threat landscape if you wish to approach security in a proper manner. Threat modeling allows you to, by using abstractions, aid in thinking about security risk. It's typically a theoretical study of the application based on a particular use case. This has been done. We have actually done it in cooperation with other organizations, for other communities, for the ROS community, for example. So we're very open to do the same. So if anyone, again, has a proactive interest on this, do reach us out. We definitely would need to define some use cases. So manufacturers or drone users out there with interesting use cases, please reach out. You've got here a few bits I cooked, which essentially present different components within the Autopilot and outside the Autopilot, interacting with other peripherals and companion computers, actuators, and other elements within a drone. You've also have here some of the communication lines drawn across different protocols and interfaces. And on top of that, you've got the boundaries. Boundaries are drawn with dashed black lines, and there are names for each one of those boundaries. And crossing these boundaries are the communication lines which define the entry points. You've got a few entry points with red or brown dots, which represent either primary or secondary entry points, which you typically get into account when you start considering your threats. And from that point, you define what are your flaws. And if you exploit your flaws, you find vulnerabilities, and so on and so forth. So anyhow, threat modeling, something missing, and something we definitely wanted to add a few bits on. So here it is. Second piece is actually second and third piece, because we'll touch here static analysis as well as flow management. Is static application security testing, SAST, or static analysis in short. Is a study of software without executing it. And there's some work already done in the community on this end. Particularly the picture you've got over here comes from the PX4 official Coverity scan, which already shows some work towards mitigation of outstanding flaws, but still quite a bit of work to do. And we identified a number of issues in the existing static analysis infrastructure of PX4, which you can see on the left side of the slide. Essentially, they only use one tool so far. So there's only one security perspective. Even though Synopsys is a huge security company, it's certainly just one security perspective. So this is something that could be improved, certainly. There's no real public transparency on the flaws. Essentially, only selected developers get a report in their emails. And this definitely decreases the amount of contributions that can come from other groups, such as, for example, ourselves. You also require a license for Coverity if you wish to locally reproduce some of these issues, which typically is something necessary if you want to speed up triage and mitigation. And finally, when we speak about triage and mitigation, you always need to speak about reproduction. In robotics, reproduction of issues is critical, very time consuming due to the complexity. The same happens in drones. So definitely something to improve. Of course, it's free, so it's cool, and it does the job for the community. It has done it so far, but definitely we wanted to contribute on this end. So here is what we've been doing on this. First thing that we did was essentially we grabbed 4 open source tools for static analysis, and launch them across different releases of PX4, official releases. I grabbed the latest one, version 1.10.2, and if this is not the latest, guys, just ping me and let me know which is. Probably I might have gotten it wrong, but essentially you've got over here the total amount of flaws, of security bugs that were identified by running these 4 tools. You do not require any license for these tools because all of them are open source. You can check their source code, you can download, you can customize them. So it's pretty cool, already fixing 2 of the issues previously identified, and also showing some interesting growth or decrease of the flaws. Especially with this latest release, we saw an increase of the flaws, so definitely willing to contribute, to mitigate, to address them, to triage them. So Alias would love to contribute more. And again, we ask for commitment from other parties as well as contributions and support. Next issue we tackled was the public transparency. So our experience so far is that triaging is very time consuming, very expensive, and having developers, security researchers, and flight experts helped very much in the discussion. So what we did is we pushed every single one of these flaws into a separate GitHub issue in a centralized archive, which we called the Robot Vulnerability Database. And again, as you can see here at the top on ticket 2640, which is essentially an overflow, a buffer overflow, it is an issue with the right tags for it to be filtered and identified, and it's open for discussion. Anyone can jump into it and say, hey guys, I don't think this is a security issue, it's a quality one, or it's not even a quality one. I tested this, I don't get this issue in my local fork, please can someone double check? Or yes, I can confirm it, and so it can get further triaged and eventually mitigated. So this is enabled and ready for these plus 500 tickets we essentially pushed for PX4. Final issue, reproduction. Still, you've got all of this information, but reproduction still becomes cumbersome because you need to go ahead, fork or clone the sources, you need to find the right line, you need to figure out exactly how to essentially trigger that so that you can reiterate on the source code, mitigate it, and then double check it. Again, time consuming, cumbersome. So what we did is essentially we put all of these bits into the ticket. And by bits, I mean we describe it by including IDs, title, informal security language. We described the system, vendor severity, we described the flaw itself. And then we have a section for mitigation, which in this case it's empty because it hasn't been triaged, and exploitation. And particularly within exploitation, we've got this exploitation recipe. All of this syntax is simple YAML syntax, super easy. And the exploitation recipe gives you a recipe for how to reproduce this. You can describe the networks, you can connect different elements, different even instances of PX4. You can describe which Docker containers you want to use to put together these images. So here we have the PX4 base image plus a few volumes that add different tools. And then you describe a flow, which is essentially a series of commands for reproducing this. In this case, it's super simple. And just with a single bash command, you can fetch the ticket from the Robot Vulnerability Database, and then you can launch the flow, again with another command. So 2 commands to reproduce this ticket. Super easy, super simple, very time efficient, and this already improves by far the experience of mitigation of issues. You can see over there, actually, I'm going to highlight right now the exact same issue. So again, I could now go ahead and just make a small change and reproduce this real quick across different tickets, across different bugs. So the overall experience gets simplified. Not just that, we can also simulate more complex environments where attackers are exploiting flaws over the network with different tools. So this is what we designed for the last few years and what we are now exposing to the PX4 community for improving essentially triage and static analysis and mitigation. So long story short, our contributions to static analysis are we've reviewed PX4 across different versions with 4 different tools. We've also contributed to getting this integrated archive of flaws, this flaw management centralized database, which we call the Robot Vulnerability Database. And we haven't just focused on PX4. We wanted to get some comparison with other open source Autopilot. So you've got here some numbers for the total amount of flaws for APM and Paparazzi as well, using these exact same tools with their latest releases. I picked the latest releases for each one of these. And this gets also correlated with the amount of lines of code which has been produced using Clock. So anyhow, interesting data that essentially tells us more about the security status of PX4, and also that all of us should probably continue contributing to improve the security, at least from a static analysis perspective. Again, all of this data is available in the Robot Vulnerability Database, so if you have interest in all of this, I encourage you to go ahead, click on this link, and contribute, not just maybe on PX4, but possibly also with other robot components or drones. Now, again, I touched into these 3 items, but I wanted to share a few bits on how to improve the overall cybersecurity of PX4. So I annotated the previous DevSecOps flow diagram and try to assess the PX4 compliance with this current DevSecOps. You've got in blue some of the items I didn't have enough time to look at, so I really don't know their status right now. Apologies for that. In yellow, the ones that I assessed and weren't up to the expectations we typically have within Alias Robotics, so definitely need some improvement and contributions. And once again, we volunteer to do so if there's people willing to support us. Particularly static analysis deserves quite a bit of work, as we saw. But also and specifically flow management and threat modeling, definitely big priorities. You can see them in red. Not just that, also things such as penetration testing, red teaming, bug bounties, or even vulnerability scans that happen periodically over the source code are things we definitely encourage. Very happy to continue the conversation on this offline. So again, ping me if you have interest on this. Again, threat modeling is something we definitely encourage. I already said it, but I just wanted to re-emphasize it here. Super important and something we definitely will be willing to contribute and cooperate with. And finally, we also wanted to just dedicate a few additional words about triage. Triage is super important. Again, in this few bits we contributed, we located more than 500 total flaws for PX4 across different versions. Again, lots of things to triage. This is not something that a single organization or a group of developers can do. This is something that requires full-time dedication and definitely something that also requires a bit of experience and expertise. So again, please consider this very carefully. Beyond PX4 development community, beyond PX4 source code, how can I stay secure if I'm a drone user that is using PX4? So we also wanted to tackle this and share with you a few of the bits that we are doing to try to help these drone users. So we've been putting quite a bit of work over these 2 past years to try to work with communities to develop what we call the Robot Immune System, which is essentially an endpoint protection platform, a series of security layers that give you proactive protection and block, prevent, and record every single interaction that the robot has with its environment, not just at the network level, but also across sensors, actuators, so on and so forth. How do we do it? Well, by using different modules that some of them use machine learning techniques to learn over time and adapt to the specific circumstances of the robot. Some others use traditional security tools for adaptive firewalling or just simple hardening. So currently we're working on this. We're working on this for PX4. And we're very, very open to your input, to your feedback. So if you'd like to try it or you have feedback, please reach us out. We have licenses for development as well as for R&D. Particularly, I'd love to call for feedback throughout that forum. I also posted this on this course. So please help us understand what are your needs. Help us understand what are your concerns security-wise. And once again, if you have actual real interest on this, just reach us out. You can see here some of the integrations we are starting to do with Q ground control. Definitely worth taking a look at things. And other than that, thank you so much for your time. Hopefully I didn't go too far, this 15 minutes allocated. And yeah, happy to continue offline with the discussion. Other than that, please stay safe and stay secure. Thank you so much.